So let us discuss about Pempigus vulgaris. At the end of this video, we'll also compare Pempigus vulgaris with Pempigus foliaceus. Okay. So what is Pempigus vulgaris? Pempigus vulgaris, it is a intraepidermal blistering disorder. Blistering disorders means in this mainly what happens is there is formation of blisters. And these blisters are formed in the epidermis. Let us see how these blisters are formed. So in epidermis we have keratinocytes, right? So if it is epidermis, this is dermis, right? This is dermis, this is epidermis. In the epidermis we have cells, right? We have cells all over here. If you take two adjacent cells, okay, these are two adjacent cells. These cells are interconnected each other by proteins called by connecting substance called desmosomes. So these desmosomes, they connect to two keratinocytes present in the epidermis. Okay. In Pempigus vulgaris, what happens is there is defect in these desmosomes. Basically, there is formation of autoantibodies against these desmosomal proteins like desmoglin 1 and 2. Desmoglin 1 and 2. Okay. Basically, what happens here is there is formation of autoantibodies against this desmosomes. Desmosomes contains desmoglin 1 and 2. 1 and 2 depending upon the site. Okay, they may contain 1 or 2 depending upon site. Okay, desmoglin 1 or 2. So these, when autoantibodies are formed against this desmoglin, it results in defective functioning of or loss of this desmosomes. This results in separation of keratinocytes, right? There is separation. Due to this separation, it results in blister formation. So this is basic mechanism by which blisters are formed in Pempigus vulgaris. So next, moving to the most important protein that is involved in this Pempigus vulgaris is desmoglin 3. This desmoglin 3, it is present in stratum basale. Stratum spinosome. As all of us know, stratum spinosome, it is a layer in epidermis, right? Okay. So there is defective or loss of desmoglin 3 in stratum spinosome. As all of us know, stratum spinosome, it is deeper layer in epidermis, right? So almost second layer from below. First, if take epidermis, this is epidermis, right? So first we have at the base we have stratum basale. Second, stratum spinosome. Third, stratum granulosum. Fourth, stratum lucidum. Fifth, we have stratum corneum, right? So this desmoglin 3 is present in stratum spinosome. So blisters are formed mainly in stratum spinosome. Okay, blisters are formed in stratum spinosome. hence these blisters, we can say they are deep in epidermis. Okay, so they cannot easily be ruptured. Okay, they cannot be ruptured easily. This Pempigus vulgaris, it is associated with HLA-DR43, sorry, HLA-DR04, associated with HLA-DR04. You see, I told you there is separation of keratinocytes, right? That means this keratinocyte, they get separated. These separated keratinocytes, they are called acanthocytes. They are called acanthocytes. So if take this is suppose basement membrane, they will get separated, right? These uh, separated acanthocytes or separated keratinocytes, they give tombstone appearance. Tombstone appearance. The tombstone appearance is because they appear far away from each other. Usually in normal skin they appear like this, right? So they appear like this, but now they are appearing far away from each other like this. This is called tombstone appearance. Okay, there are acanthocytes which are separated from each other, so it gives tombstone appearance. These desmoglein 3, as I told you, they are present in stratum spinosum, right? This desmoglein 3, it is mainly present in buccal mucosa. Buccal mucosa. So usually blisters are seen in buccal mucosa. Okay, this desmoglein 3 is present in stratum spinosum, which is mainly stratum spinosum, and this desmoglein 3 is present in buccal mucosa. Hence blisters are seen in buccal mucosa. Later on, if the disease progresses, even desmoglein 1 will also will also be destroyed. Okay, desmoglein 1 will also be destroyed. This desmoglein 1 is present mainly in skin, especially in the skin also, especially in the layers of epidermis, mainly stratum corneum. Okay, so initially there is destruction of desmoglein 3, but as the disease progresses, even desmoglein 1 also destroyed. This is present in skin. Okay, this is present in skin, especially stratum corneum. Hence we can say initially blisters are found in mucosa or buccal mucosa. Later on, blister will also be formed in on skin, especially on trunk. We can say trunk is more involved. And then moving to clinical features. So clinical features, mainly there is formation of blisters, right? Blisters will be formed. The sites being buccal mucosa, scalp, extremities, trunk, perianguinal. Okay, sites are oral mucosa or buccal mucosa, scalp, even extremities, and trunk, etc. And there are certain important signs in in this vulgaris, the signs are, one is Nikolsky sign. I will write it here, Nikolsky sign. Let us see what is this Nikolsky sign. So basically what happens in this Pempigus vulgaris, there is formation of blisters, right? There is formation of blisters. So we can say blisters are formed, right? When you apply pressure, on these blisters, what happens is there will be separation of epidermis. There is separation of epidermis. Okay, when we give pressure either tangentially or perpendicular, whatever it is, when we apply pressure on these blisters, there will be separation of epidermis. Then we can say the Nikolsky sign is positive, and this is positive in Pempigus vulgaris. This is one sign. One more sign is Bullae spread sign. Bullae spread sign. Bullae spread sign. And one more concept that I forgot to tell you here is, what is blister. This is, we are not talking about Bullae spread sign. I am giving just idea of what a Bullae is. Okay, I'm telling what Bullae is. So blisters are mainly of two types based on size. Okay, based on size, blisters are two types. One is vesicles, other is Bullae. Vesicles, they have the size less than 0.5 centimeters, whereas Bullae, the size is greater than 0.5 centimeters. Okay, based on size, we classify blisters into two types. One is vesicles and Bullae. Vesicles, they have the size of less than 0.5 centimeters, whereas Bullae, they have the size greater than 0.5 centimeters. Okay, this is about blisters. Then we'll move to Bullae spread sign. Bullae spread sign. Here what we do is, this appears to be similar to Nikolsky sign, but there is lot of difference. This is blister, right? This is blister. What we do here is, we'll apply tangential pressure, or else, or in case of small blisters, we apply perpendicular pressure. Okay, when we apply pressure, this Bullae will spread like this, will spread forward like this. So actually, before applying pressure, the Bullae is only up to here, right? When we apply pressure either tangentially or perpendicularly, in case of small blisters, the Bullae will spread, right? Bullae will spreads. This is called Bullae spread sign. Okay, in case of small blisters, what we do is, we give perpendicular pressure. We give perpendicular pressure. Remember this. In case of large, we'll give tangential pressure or tangential push. In case of large. Okay, this is Bullae spread sign. Then move into the features of histology. The features of histology. Histology features. So I told you there is separation of cells, right, in the epidermis. These are called acanthocytes. Acanthocytes. These acanthocytes are seen under microscope. And one more I told you is tombstone appearance, right? Tombstone appearance. So this tombstone appearance also will be seen under microscope. Tombstone appearance in the sense, these separated acanthocytes, okay, they give the appearance of tombstone. And one more sign is direct immunofluorescence. Indirect immunofluorescence. what we see is, we see fishnet like pattern of IgG antibodies. Fishnet like pattern. Let us see what is this fishnet like pattern. As all of us know how a fishnet looks like, right? This is how it looks, right? So it will have like this fishnet, right? The similar appearance we'll see in direct immunofluorescence. The reason is, these are acanthocytes, right? These unseparated, sometimes this there will be unseparated acanthocytes. Sometimes epidermal cells will not be separated. They have still this desmoglein, right? So what we do here is, we are there is formation of antibodies against this, right? So antibodies will come and bind here, all this, right? So under immunofluorescence, this will be seen as fish net like appearance, like this. Okay, this is fish net like appearance, and we can also see in the presence of autoantibodies against desmoglein 3. And then moving to treatment. So as I told you, it is autoimmune disorder, right? So in autoimmune disorder, we'll try to suppress the immunity, so we'll give steroids, mainly dexamethasone, azathioprine, cyclophosphamide, okay. These are the important drugs that are useful in Pempigus vulgaris. And we can also give one more biological drug called rituximab. Okay. In severe cases, we'll also do plasmapheresis. This is for severe cases. Okay, this is about Pempigus vulgaris. Thank you for watching.